YouTube? It's been a hot minute. As you can see, the past couple of weeks, I've been pretty busy. We've got, I would guess, something like 75% of all of my internal cabinet structures built, but by no means finished. This is gonna be like the fridge, freezer, pantry, and then a very minuscule hanging closet. Obviously, we've got our bed frame. And then over here, this is gonna be the kitchen galley, 6 feet long. Yeah, the bed frame is basically hard mounted to the van. The bed structure itself was hands down the easiest structure to design and kind of prototype and assemble all at the same time. It still took me a couple of days to assemble, but I was also learning how to kind of work with the 80/20, all of the various fasteners that are involved, the hardware, and then also interfacing between the extruded aluminum and the van itself. So that meant installing a whole row of plus nuts and drilling, like boring through some aluminum to give me basically a mounting point to then build off of and build the bed structure. This aluminum I actually got from a local company. I didn't buy this from 80/20. I went and picked it up in Salt Lake City from a company called Bonnell Aluminum. The product is called T-Slots, and they were actually cheaper than buying it from 80/20. Also, because I was able to go pick it up in person, I was able to purchase the aluminum in 20-foot lengths, which is less expensive because they don't have to charge you for each of the cuts to cut it down to like the 8-foot maximum length that they can ship. But remarkably, of all the aluminum that you see, about a third or more, it's probably closer to about half of the total cost of all this aluminum isn't the extruded aluminum. It's all of these stupid fasteners and these little inside L brackets, these inside corner brackets. Some people, I've read a variety of forums, they try and make their own. They're not gonna be as accurate, nor are they gonna be as strong, and might just cause more headache down the road because your connections aren't fitting at a nice 90 because your little homemade L corner connectors aren't accurate. So it's kind of a catch-22. But yeah, extruded aluminum has been a learning curve to work with. There's definitely some pros and cons. I wouldn't say that it's all upside as opposed to just cutting everything out of plywood and making kind of a more traditional cabinet structure. There are some benefits in that it is so modular, it's like repositionable. If you decide later on that you're like, oh wait, this shelf isn't quite the dimensions I want, I can actually raise or lower this entire shelf, or I can change the dimensions of any of these cavities fairly easily. You know, sometimes you might have to recut or replace 1 or 2 rails, but all of the other components are still reusable. Like, you don't lose any of the corner connectors if you decide to change a dimension, which I've had to do on several of these guys. I have had a couple of recuts, but even then, because you're using like the exact same component, if you cut, like if you have a quote unquote scrap piece of extruded aluminum that's, let's say, you know, like 20 inches long, all you have to do is find some other component somewhere in your build that's less than 20 inches long, and boom, it's instantly reusable. You know, you can just cut it down to whatever that different length is, and you actually have a lot less scrap. So I have honestly hundreds of feet worth of aluminum in here, and my entire scrap is less than about a foot of aluminum, is my guess. So I've managed to minimize waste. So there are some upsides there, whereas with a plywood sheet, if you mess up a cut, sometimes it can be really difficult to find a way to maximize your repurposing of that scrap sheet of plywood. Sometimes it's not so bad, but depending on how you know, the dimensions of that particular board. So there, like I said, some pros, some cons. One of the real big learning curves that I stumbled on kind of early on was these inside corner brackets. You cannot have any of these on the inside face where you want to have a drawer or cabinet door face. So I just have this eureka moment. Most of my build is built around these inside corner connectors. It's debatable as to if they are the most economical. Upon initial glance, I thought they were the most economical way to do a corner connector. But what I learned is that the anchor fasteners, they're a lot more competitive in pricing than I initially thought. And there's a couple reasons for that. Number one, the anchor fasteners, you only really need one. With these corner connectors, most likely you're gonna need two to get a similar amount of load capacity as one of those anchor connectors. So, number one, it ends up doubling the price as far as the corner connector. Number two, for the corner connectors, to do two, you now need 4 sets of screws and then 4 sets of these economy T-nuts. And so it all adds up. And so the anchor connectors are actually much more competitive or, you know, comparable than I thought. Another issue is that, this is uncomfortable. Another issue is that these inside corner connectors take up physical space. So this right here, what you're looking at, this is supposed to be my wardrobe, all 6 inches of it. But the issue that I was realizing as I was assembling this is that I want my drawer and door faces to be inset of the aluminum. That would mean that the door face is actually going to occupy the exact same space as these inside corner connectors. After a little bit of thinking, what I realized is that you actually can in fact still use these inside corner connectors and have them not occupy any of the same space, and you can achieve a flush face, you know, cabinet door with these inside corner connectors. The issue is you can't have these on the vertical axis of your door faces. They have to go on the horizontal axis. So let me show you an example. Oh, what's up, guys? Oh, golly, ow. Oh. Okay. So this is the best example I could think of. We have a horizontal support and there's no corner bracket occupying the same space that you would have like a drawer face or a cabinet door. And to do that, you just have to orient the inside corner bracket to be horizontal. So for example, on the sides of your cabinet, you can have your inside corner bracket still running, you know, on this, like, I keep calling it like the vertical axis. No issues as far as your cabinet door faces. And that then gives you, you know, an east-west orientation support that you can then mount and brace off of on your north-south orientation, you know, horizontal support. So now I just have to like undo a whole bunch of freaking things. But they do say kind of like on a lot of extruded aluminum forums that these inside corner brackets really are designed for kind of like they call it rapid prototyping. And that really is kind of just like fitting your structure, creating the structure, you know, can you physically get the dimensions correct? You know, where do you need all your different supports? But as far as like your final positioning, you can of course still use these inside corner brackets, but they are limiting in that, just like in this example, I cannot have a support running here. And so you have to, you know, build a side support. You have to kind of design your entire structure off of the fact that your supports now have to be on this like horizontal axis in order to not create clearance issues down the road. So it was a little eureka moment that I had, figured I'd share, because I'm sure some of you guys will appreciate this. Once you realize that, and then build accordingly, like you have to make sure you're assembling from the jump with this in mind, and therefore just have all of your inside corner connectors in between the wall structure or in between the shelf structure. You have no issues. You can keep those cabinet frames clear, but sometimes that does make it a challenge, because now if you're wanting to put like a wood panel or something to completely cover this side, it's it's really difficult. You're not gonna be able to use an inset panel and these inside corner connectors because, again, they'll want to occupy the same space. So now you're forced to move your panel outside. So that's one thing that I'm not 100% sure what the solution to that problem is going to be in my build, but it's something that I'm kind of already aware of, and I've been brainstorming various ways to solve that issue, but something to, I guess, keep in mind. If you guys have any questions about working with extruded aluminum for framing inside a van, let me know, and if I can, I'll do my best to try and help answer those questions. But it's been moving along pretty quickly, to be honest. You know, all of this we've done in about 2 weeks, and in that same 2 weeks, I had to come up with my entire floor plan. Basically, I had to sketch all these cabinets from scratch. I was taking kind of just like rough estimations and ideas and putting them to paper for the first time, and then prototyping, and then the final assembly, kind of as you see here, all at the same time. It's been a fairly enjoyable experience. You know, I don't think I've had any real major frustrations, and all I'm using is chop saw with a aluminum, like a non-ferrous blade specific to like aluminum, and that's about it. So yeah, like I said, if you have any questions, let me know, but I will see you guys in the next video.
I'll be documenting and sharing everything about this DIY van conversion. If you'd like to follow along, by all means, hit that subscribe button.